this second one is also. Remember, these are 2 quiz points on every assignment. All right, you need to do these. These questions are the first 2 questions on your homework. All right, EOC is always the first questions on your homework.
Do I give it to you?
No, you need that for your project. Okay, so we're now working on those circles, and you have to, if you're A, you're probably the front yard, and if you're B, you're probably the backyard. All right, so get a sheet of paper out, and we're going to get started on section 3.5. Why I'm doing this, we're going to need a sheet of patty paper. If you are low on patty paper, I'm passing around our patty paper so you can get some and put it in your notebook because you're going to need it. This is 3.5, and I think you know what I'm about to teach, but we need the vocabulary. So, classification, we can classify triangles by angles or by sides. We're on triangles for like at least 9 weeks. There's going to be some consistency here. An acute triangle is a triangle with all acute angles. Do you remember what an acute angle is? Less than 90. Obtuse triangle is a triangle with only one obtuse angle. These are 3.5. And by the way, they are online if you had downloaded them. I did get it ready for anybody that likes to use the notes. A right triangle is a triangle with only one right angle. What do you think equiangular? What 2 words do you almost see there? Equal angles. So this is a triangle with, all equal angles. Brian said 60 degrees. Now, where did he get 60 degrees from? Okay, you know all angles add to 180. There's 3 angles in a triangle, so each angle is indeed 60 degrees in isosceles triangle. Isosceles. And an equiangular triangle. Can someone tell me why we only can have 1 obtuse? That we can't say all obtuse or 2 obtuse? How many degrees in a triangle? 180. And if you have 2 obtuse, what will 2 obtuse angles do? Go over 180. And you don't even have a choice of a 3rd angle, do you then? Why can't we even have 2 right angles? It would equal 180. You have no room for a 3rd angle. So there really is a reason for all, only one, only one. And that was another slide, and we'll be able to skip that now. An equiangular triangle is also acute. That is correct. An equiangular triangle can never be obtuse, nor can it ever be right. Those are good questions. Uh-huh.
So like right angle is 90 degrees, so could it have to be 180?
How many angles in a triangle, though? So that 3rd angle would be how many degrees? If you had 3 right angles, it would be 270. If you had 2 right angles, there's a 90 and there's a 90, you don't have a triangle. Okay. Yes? It will be by the end of 3rd period. Okay. That's your assignment sheet that you have in your notebook that you know what I mean. It is worth downloading. It's worth printing. And then you've got that there at your fingertips. All right. Now we're going to classify triangles by sides. Scalene, isosceles, equilateral. What do you think? Equilateral. Do you know what lateral means? Okay, lines. And lateral usually refers to sides. Okay? So we'll start there. An equilateral triangle is a triangle with all equal sides. And if you had that, you'd have those little tick marks everywhere, correct? Scalene is a triangle, just the opposite, with no equal sides. And because we did the syllabus on like Friday, I believe section 6-7 goes there. You have to know this through chapter 6. And this is actually in unit 7. So this is going to come back to us in unit 7. An isosceles triangle is a triangle with, and this is a key, at least 2 equal sides. What does that mean? At least. It could have 3, meaning an equilateral triangle is also what? Isosceles. But is isosceles always equilateral? Because isosceles could have just what? 2, and on the equilateral you have to have 3. How many people knew these words already? Okay, this should have been, I think, old stuff. But we're going to bring it back because in 6-7, on a coordinate plane, you're going to have to show that a triangle is scalene, or show that it's isosceles, or show that it's equilateral. So if you don't know these definitions, then you're sorry out of luck. That's called SOL, in case you wanted to know. SOL, sorry, out of luck. Yeah. I don't know what you all think that means, but it certainly doesn't make sense. Am I taping? Yes, I am. All right, I'm going to move on because these will be online. All right, the sum of the measures of the angles in every triangle is 180 degrees. We learned that first semester. So now let me show you y real quick. This is kind of a geometry y rather than a 6th grade y. Do you see those? What do those arrows mean? Okay, so now we're gonna dig back into first semester, and if I trace the sides of angle 1 and I trace the sides of angle 4, what letters formed? A, Z. What kind of angles are these? Alternate, interior, and I also heard congruent. And the reason why they're congruent is because the lines are parallel. All right, so let's trace the sides of 3. There's angle 3, and we'll trace the sides of angle 5. What do they form? Oh, and so because the lines are parallel, what type of angles are these? Alternate interior. By the way, we're going to revisit this in section 8-4. Okay? That shows parallel. Those are the arrows. Okay? Now, what do you know about this? If you added 1, 2, and 3 together, what would the sum be? Because this is a straight line. So you know 1 plus 2 plus 3 equals 180 because the outside sides form a line. What equals angle 1? What angle? 4. All right, 2 doesn't have an equivalent. What's equivalent to 3? All right, so what I just did is I just did substitution. Okay? And what do we have? We have 4 plus 2 plus 5 is what? 180. The sum of the angles of a triangle is 180. And now that is a 10th grade level geometric proof. 6th grade, we would have taken the triangle apart and put them together and showed this relationship right there. But we didn't have time. It's one of fun investigations. Notice I planned in the summer that we would do that, but I didn't know how tight the county would make us on our timeline. All right, we already talked why one obtuse angle only has one. A triangle can only have one obtuse angle and one right angle. So we're going to skip this slide. All right, here we go. How do we find x? 49 plus 56 is going to be 9, 10, 105. Subtract that from 180, and we're going to get 75. Do I have to see this work? If I don't see this work, will you get credit on your homework? No. All right, what do these two little arcs down here mean? Congruent. So if this is x, what is this? Let's see if I can move this without, oh, everything does move with it. Oh, no. Okay. So if this is x, this must be, all right. So let's do I know y? Do I know z? And that's are two different variables, aren't they? But these are two of the same variables. Can I work inside this triangle? So what do you know? Okay, so hold on. Let me move this. Don't you wish you could do that on your notebook paper? 180 minus 28 is going to be, I think, 160, 152. And then what do we do with 152? 152 divided by 2. 2 goes into 15, 7, 14, 12, 76. So this is 76, this is 76. Now, could we have written 2x plus 28 equals 180? Yes, we could have done that also. We still would have gotten 76. All right, so what's the relationship between x and y? Y. They form a T. It's a straight line. So how do I find y? 180 minus x, which is 76, so this is 104. So now that we know y is 104, how do we get our z? 51 and 104 is 155. Then we're going to take our 180 and subtract our 155, which is 587. I think that's 25 degrees. What? Oh, well, did you see that? What we're doing now is we're focusing on a new triangle. Yeah. And what do you know about those angles? And we already found y, so I added 51 and I added 104. How did I get y? Okay, what do we know? And I know you know this, Lizzie. What's the sum of these two angles?
Oh, 180.
Because it's a straight line. Right, that's my y part.
Okay.
So then we added these two, and we took that sum and we subtracted from 180 to get z. So do you see why I combined these two sections? Because this is really old stuff. All right, I'm going to jump to another diagram, and I want to look at this one. If I told you 12 is 57, and I told you, oh, that's not fun. Hold on. I want a more fun one. 2, 11. Okay, we're going to do number 2. If I told you 2 is 100, and I told you 11 is 140, and I want to find angle 7 and angle 3, what do you think you're going to have to do? What do you think your goal is? All right, you want to try to get in, you want to get inside the what? You want to get inside the triangle. So if you know 11 is 140, how do you get to angle 12? 180 minus 140 is equal to 40. So that means 12 is 40. We did that because that's a supplementary relationship. How do you get angle 3? 140, oh. Where did I get 140? So I said 100 plus 40 is what? And then what do we do to get angle 3? 180 minus is equal to 40 degrees. So this is 40 degrees. How am I going to get angle 7? Which 40 are you subtracting? The 3, that's correct, because this is a what kind of relationship? It's complementary? Linear pairs. All right, what if I had asked, what if I wanted angle 10? Why? Vertical, and you're going to need this in chapter 4. What if 3 is 40, what's 8? 40. If 2 is 100, what's 5? Notice my diagram's not drawn to scale. If 2 is 100, what's 6? 80. If 6 is 80, what's 1? 80. If 12 is 40, oh, if 11 is 140, what's 9? Okay, we already found 7 to be 140, which makes 4 what? So you could get every single angle up there. Okay, so that's part of your worksheet too. But then one other piece I did is I gave you the inside angles. So what do you write?
2x minus 5 plus 2x plus 3 plus 2x plus 11.
There you go. I bet you could have done that without this lesson. What's 2 and 2 and 4? 8x. What's negative 5, positive 3? What kind of 2? Negative 2 plus 11. All right, what do we do with our 9? So we're going to get 171, and then what do we do? And 8 goes into 17 2 times, which is 16, which leaves me remainder 1. 8 goes into 11 once, which remainder 3. I don't do decimals. So much easier to do fractions. So, what do you think? Easy? I think that's it. Oh, really?
Yeah.
Oh, my, look at that. I don't think we need that. I am. I was just looking to see where I was going.
So are we done with those?
No.
What is that? What is the x equal?
21 and 3/8.
No, no, no.
8x equals 171 over 8. Yes, sir. Yeah, I'm starting on a new piece. All right, you got patty paper, right? All right, so I'm going to pause this. Who's going to remind me to unpause this? Notes? Your homework is 2 worksheets. I've tried to condense this unit because it needed to be done for semester. All right, this is important. You must know the vocabulary of an isosceles triangle. Notice the 2 equal sides come up, and these 2 equal sides form the vertex angle. So how do you find a vertex angle? You find the 2 equal sides, and in the angle formed by those intersecting sides is the vertex angle. The side that is not equal is called the base. Now, does the base have to be on the bottom? Bases does not mean bottom. That was not very straight. What happens? Yes, I did. All right. So that's my base. So what if I were to draw this triangle and I told you those 2 sides are equal? Where's the base? Well, let's say this is WIN. Where's my base? IN. That's going to be the base. Where's the vertex angle? W is my vertex angle. All right. So the angles formed by a leg and a base are called base angles. Right? There's 2 of them, and part of that, one of the sides of a base angle must be the base. So you need to know this vocabulary because I will be using it. This over here, I just did another example to show you that the base doesn't have to be on the bottom. Okay, so often we think of a base, you know, the base of a figure or the base of a, I don't know, vase. It's the bottom of it. I don't want you to associate base with bottom. Okay, the base, notice, is kind of on top over there. All right, do you have your picture drawn? You have it labeled? Okay, you could even label it on your patty paper if you want. I suggest you either staple your patty paper or tape your patty paper to your notes, but not at this second. All right, so now I have too many thes, just FYI. Does that bug you? Da-da? All right, if that bugs you, we'll get rid of one. Okay, so probably bugs you more. If 2 sides of a triangle are congruent. Oh, I know what I was supposed to, it should have been then the opposite, then the Okay, I'm trying to get my words right. Here we go. Angles opposite those sides. I was putting opposite before angles and it didn't make sense. Then the angles opposite those sides are what? Congruent. That was an investigation in your investigation section. Then the angles opposite those sides are congruent or equal. It's up to you. So you might want to look at page 8, investigation, when you go home. And you might want to write the summary there so you'll know. So that's one of the biggest things we're learning today. Now, we learned this first semester. I'm going to go back over it. We also learned in our first unit, if a point is equidistant, it's always good to bring back old stuff, from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So I also want to bring in unit 2. This means that the line of symmetry in isosceles triangle is the perpendicular, you might as well abbreviate when we can, right? Perpendicular bisector of that side. Two ways of looking at it. It's usually a concept is more deeply understood when you come at it from different perspectives. So what I should have done is I should have had you write problems based on that foldable or that little patty paper thing. I bet you could have written some good ones. And I know, and I have 2 sections, so I got 7 minutes. All right, so I'm going to go on. Okay, you got it? And then it's the second time. Okay, so I gotta get to the point where you can do your homework. Okay, so here we go. Notice, did I draw you a picture? Okay, I could not do this problem without a picture. I don't expect you to be able to do this problem without a picture. So what do I expect to see? Okay. No, you don't. There's no way I could have done it without it. All right, so TRI. So in triangle TRI, I is the vertex angle. If I is the vertex angle, then I should know which 2 sides are congruent. Those are angles. I need 2 letters to name a side. T, I, and, okay, and this is what I will do, and I will do this on the test. I will tell you this is 3x plus 4. I may tell you that this is 4x plus 1, and I might tell you that this is 5x minus 8. And I will ask you to find x. Now, those are not angles. Those are sides. What would you set equal? Yes. You would have to set equal 4x plus 1 equals 5x minus 8. Why did I give you this? I gave it to you to see if you understood the concept. If you set these 2 equal to each other, then you don't understand what a vertex angle is. You with me? Okay. Obviously, well, I'm telling you, I've done that on your worksheet, and I'll do that on the test, because that tests you. Because vertex angle, the 2 congruent sides form it. Okay? So that's a key word. All right, by the way, they told us that this vertex angle is 42. So I don't know T. What do we know about R? Is it X or is it 42? It's X. All right, because the side or the angles opposite those sides are congruent. So 2x plus 42 is equal to what? 180. So we're practicing that concept from 3.5. So we've got 2x is equal to 138. Then we're going to divide by 2, and we're going to get something. 69. All right, how else could I give this to you? So I've kept the vertex angle where? Too bad. I switched it on the worksheet. So I is the vertex angle. So the first thing you want to do is mark your diagram. T now is 58. You are supposed to find I. How are you going to do that? Okay, who else is 58? All right. So we're going to take 58. We're going to multiply it by 2. Then what? 180 minus 116 is 70, 60, 64 maybe? Do you like this so far? Is this a good place to start? We literally are in triangles for like 9 weeks. Mm-hmm. Yes. Yes, the two equal sides form that vertex angle. All right, so now how else will I do this? All right. You know I couldn't leave algebra alone, correct? So we've got BAT. Now it says angle A, oh wait, vertex angle is B. Whose sides do I mark? BA and BT. All right, so A is 3x minus 4. B is 2x plus 1. My question to you, is T 2x plus 1 or 3x minus 4? All right, why didn't you say 2x plus 1? Because that's the vertex angle. Base angles are equal, not the vertex angle. So now how are you going to solve for x? All right, so we've got 3 plus 3 is, and 2 is, so I've got 8x, negative 4 and negative 4 is, negative 8 plus 1, negative 7. I don't think I wrote pretty problems. So you're going to add 7 to both sides, you get 187, and it's odd, which means 8 will not divide it evenly. So x is going to equal 2, which is 16, 27, how many 8s are in 27? 3. Let's see, 8 goes into 27, that's 24, 25, that's going to be in 3/8. Now, they said to find angle T, what would you have to do? Go back and do what? Substitute. All right, so don't pack up yet because I got 3 more minutes. And my clock is fast. If a triangle has 2 congruent angles, we're doing the converse, all right? Now what you're going to be told is, let's say this angle is equal to that angle. If you have 2 congruent angles, what do you know about their opposite sides? They're going to be what? Congruent, okay? Then sides opposite those angles are congruent. All right? So if this is HAT, who is the vertex angle? T. So if you see 2 congruent angles, I want you to immediately look for equal sides. If you see 2 equal sides in a triangle, what do I want you to look for? 2 equal angles, correct. It goes both ways. Okay? You've got, look for 2 equal sides if you're given 2 equal angles. If you're given 2 equal angles, you look for 2 equal sides, yes. All right, where are the equal sides? All right, so what must the angle be? Find the equal sides, take your fingers, trace them to the angle that they form. All right, so now what have I done? I have said that triangle, CAT, So now I'm working backwards here. We've got CAT. Angle C is equal to angle A. I have told you CA, this side, is 3x minus 4. AT, this side, 5x minus 9. And CT, this side, 2x plus 15. Find the value of x. These are not angles. We do not add these and set them equal to 180. You have two equal angles. What are you supposed to look for? Equal sides. Where are they? CT is 1. And CA, this is opposite that angle. This is opposite T, and it's not equal. It is going to be what? AT. So what's your equation? Yes. If you had set either one of these equal to that, it would have been wrong because that is the base, not the legs. So if we subtract 2x from both sides, that's going to be 3x minus 9 equals 15. If I add 9, I have 3x equals 24. X is equal to 8. The sides, you mean? It has to do with the angles. All right? Find your angles. You see my angles? Then you have to say what's opposite that angle. This side, right here. Okay? Thank you for waiting. Thank you for waiting. You see this side? That's opposite that angle. So now what side is opposite this angle? This one. This side helps to form that angle. This side helps to form that angle. It can't be opposite. So find your equal angles, and then you can find your congruent sides.
So what are the angles that's the side?
T, what does that make T? If these are the two equal sides, what does that make T? The vertex angle of an isosceles triangle, because an isosceles triangle has at least two equal sides. I'm done. All right? Do I have a stapler?